So thanks everyone for coming to my talk. Again, this is Preflight Your Data. I have a product background. I worked in software for over 10 years, and then I actually was a bioinformatics major to begin with, but I never finished it. And at my sabbatical, I went back and I did the certificate program and got back into the science side of things. So I started working on a project called FAIRY, and it's based on the FAIR data standards. The name is just based on the FAIR data standards of that your research and data that you submit should be findable, operable, reproducible. I'm forgetting the I. But then I was working with several bioinformatics and also like natural history museums about submitting their data and making sure that it was repeatable. So that's the start of FAIRY, and some of the talk that I give is based on the work that I did for that. So we will start. So most broken data sets don't look broken. This is a tiny sample from some OBIS data. This is specifically about California mussels, and I was working with a group that they were translating data that was coming off of fishing boats and manipulating that data so that researchers who are studying like fish migration patterns and things like that would be able to consume the data that was coming off the boats. So the fisher people were less technical, right? And so they didn't have as much experience with the metadata formatting and all this stuff. And there's a lot of workshops that they have to go to and, follow up to get the data into the right state. So this is just an example of some data that might look fine, but it's actually broken once it's passed off to the next people who are looking at it. So a lot of these hidden issues, they survive handoff because it looks fine. So in the past example, there were some coordinates that were 0, 0. And for that specific geographic location, that's not accurate. It was actually just a placeholder that was put in there. So all the data was actually filled in for that column, and it looked right, but then it gets passed on to the next group who says, hey, that doesn't make any sense, or did you mean to put that there? So again, with the other groups I've worked with, also there were issues with the way that things were named, taxonomy issues, like the scientific name of whatever mouse that you were studying, or whatever, if you're going to call it a mussel or if you're going to call it by the scientific name, because later on when it's in a repository and you're searching for that data, it's going to be harder to find, or it's not going to come up. A lot of issues with dates. I think that's pretty universal across all kinds of data, right? So the month and day is like swapped, and it looks fine. It's kind of weird. We don't know what format it's supposed to be in. Duplicate IDs, a lot of copying, pasting rows and things like that, or you're making updates, you actually update the wrong one, and then you have duplicated data. And then missing link sample is interesting. So when you're submitting this data, sometimes the information that's in one file needs to be cross-referenced with another file. And again, if you have multiple files and updates and things like that, and you upload the wrong other file that doesn't have the information that you're cross-referencing, that is an issue that will be downstream. You might have uploaded the right number of files and they're not the right files. So again, these patterns are common across all types of data sets. So data doesn't structure itself, right? There's a lot of people working on it. And it starts with this workflow where you have a bunch of spreadsheets maybe, and you're inputting this data, again, with a bunch of rows and multiple people working on it if you're on a team. A lot of emailing back and forth about updates and prepping that data to be submitted. So you might create some checks, you might even write some Python checks to make sure that all the rows are filled in and things like that. And then the file looks ready to go, so you submit it, and then once it gets submitted, it's caught in this repository purgatory where somebody is actually on the other side reviewing the data and again seeing like, hey, these look like placeholder data, emailing back and forth again, and it's not the most efficient workflow. So these patterns survive because the whole process is still pretty manual, even if you're automating a bunch of stuff. There's still humans at the other end of the data that we're consuming often, and yeah, it needs to be formatted correctly. So what I mean by pre-flight, this is how I was working on these projects with the ferry data. So first, validating. So you're running validation checks and checking for basic things, required fields, formulas, IDs are all in the way that you would expect. And then we go on to reviewing the findings. So again, this relates to those Fisher people who were submitting data where things might need to be checked, and they need a human way to view that information and understand what needs to be checked quickly. If you're looking at a bunch of transaction logs, it can get kind of hairy. So reviewing what needs to be fixed and also why it matters. So if it says like, hey, this date is wrong, giving them more information about, hey, the date needs to be in the ISO format, or you can give them additional information about how to fix it. So then after that, you can package and share. So creating a shareable report and deterministic outputs. Deterministic meaning if I run it today and I run it tomorrow, it's going to be the same outcome, and it's still in the same format, or we know that we're looking at the same file that was submitted. Also validating the metadata, making sure that all of the structure is there for whatever repository that you're submitting to. And then if there are fixes, then you can rerun that validation loop. And again, using that ferry software in my example, where it's reviewing what changes have actually occurred after you've made fixes. So it'll still point out, you need these additional things, or we have these warnings. So also, in my experience, you don't need a ton of rules. You don't need a huge infrastructure to make it worthwhile. So I started small. I would work with these groups with like maybe 5 to 10 rules that I would create for them, or help them create themselves. And I had some examples from the OBIS data. So occurrence ID was required. We wanted to check for the duplicate IDs, the suspicious coordinates, invalid ISO dates, and the country codes. So country codes like you write US or USA or things like that were coming up quite often, especially with these boats that were going around different locations. And with those checks, we also had severity levels. So sometimes you don't want the file to go to the repo if it's got these super failures. So a lot of the ID checks were fails, but you could have warnings. So again, you might not have placeholder coordinate values. Those might actually be valid, and somebody has checked them. So it would warn on the first run, and then on the second one, you could bypass that and say, that's fine, I've checked it. And then at the bottom here, I just had the script to run in the command line, the ferry validate. So it would take in the set of rules that were written, so that was in the rule pack, and then the source file, whether it's CSV or TSV, and then the last 2 lines are the reports that you could generate. So there's a JSON that's more for like machine consumable, and then the Markdown report, which is more human readable, where it has the additional information about like, hey, this is what you need to fix or why. So getting into the Python architecture, start with a YAML file. And again, this is an example from this OBIS data where we're looking at decimal latitude and the suspicious coordinates. And this is important because it's a reusable sort of tool. So again, this is a regular expression, and we have the severity that's a warning. and then some configuration information about where it's coming from in the TSV, and also if the mode is matching or we're looking for the opposite. So these checks are small and they're declarative. And this is the same YAML. It's flowing into Python, right? So then we have the rule pack loading and reading through all the text of the file. And then the report is running through the rule pack and making the checks and creating the reports. So the flow is basically the rule pack YAML to the findings that are in the JSON file, which is the machine readable one, and also the report Markdown, which is the human readable file. Oop, did I go back? Also, the structure of the findings is pretty important. So we have the data class with the code is in string, and rather than like printing outputs in the command line or into the terminal, the biggest shift was that we're using objects. So this is an example of the finding when it's translated. So we have, again, that you can write out more words and explanations to people who are looking for them. So in this example, what is this example? We have an unmatched ID in the sample. Severity is a fail, and where and why, and how to fix it. And all of that is configurable. The structure could be updated based on whichever group is writing the rules. Also, a lot of the findings and rules were based on common patterns that were seen with these groups. So they could add additional rules based on what they saw. And again, I just started small, and it could be expanded. So the human readable reports was especially important, and this would be an example from a Markdown file that was generated on what to fix first. So we would resolve all the fail findings, right? So the file wouldn't be able to be submitted to the repository if it's got failing checks. And then you could rerun the validation if there are fixes that need to be run, and review the remaining warnings and either pass them or not. And the Markdown would give you a summary of all the changes that had occurred. So in this case, it had one fail and one warn, and it's telling you which rule and what row to go to in the file and make updates. And again, this is pretty important for collaboration for these groups, because if you're emailing back and forth, like, hey, go to this row and fix this, and they can just rerun, in my example, Fairy over and over until they pass all these warns and checks. And it is pointing out exactly what's going on. So grouping the findings is important, and all the row level references and what actions people actually needed to take. So this is an example of invalid and unmatched IDs in a sample. And this is the actual Fairy Preflight that I wrote. So the rule pack, this is for submitting to Geo. And it has all the metadata that needs to be included. So at the top we have, the runtime and which rule packs is in addition. And then we have the fail findings and the warnings. And this one we've just selected to output the JSON machine readable file. So in this example, the context is missing, and each sample needs a biological source in order to fix it, so provide at least one tissue cell line, or cell type. And again, that would be something that the institution had knowledge about and had seen previously in the past that wasn't caught by the repo, and they're encoding it into this validator. So The important part on the end is that we have the resolve since last run. So again, if you're rerunning Fairy over and over, you see what updates have been made. It's not on this example, but there's also some hashing in the background. So you could actually check which file was run for and at what time, so that even if you input the same file twice, it wouldn't make an update until the actual things were resolved. So it helped with organizing all these different files and things. So yeah, the validation becomes more useful when reruns are clearly showing what has changed, and people can go back and reference it. And especially with this is a biological context, right? So long-running experiments and research work and lots of file sharing between different people or people who have left and maybe you're picking it up from another project. This can become super important. So yeah, again, it's starting small and local, writing those basic rules can really save a lot of time and make the workflow faster. And the whole point of this validation is to actually catch these issues that are coming up earlier in the process. Making validation reusable is helpful for the teams, and then optimizing for humans, because again, in the workflow, a lot of people are collaborating, and even if AI is consuming it later or something, a lot of our data is used by humans, and it's important to optimize for the people who are actually working with it. So I have a link to my GitHub repo if anyone wants to check it. There's some examples and some quick start runs you could do also if you just want to manipulate files and things like that. And yeah, I'm Jennifer Slotnick. You can find me on LinkedIn as well. So thank you very much.